Welcome, Hornets, and thank you for joining me today. We're going to be talking about finding domain of a logarithm. This is one of our first skills. Before we can solve, we have to find out what values are acceptable for us to use. And it's not that difficult. So let's go ahead and just get started. I hope this works for you. And remember, if you do find this a reasonable video, please make sure you click like. And if you find that there are problems, please remember to give me suggestions. So we're going to start off with our first equation, y equals log base 2 of x plus 2. Now, the whole idea is that we have a function that has a vertical asymptote. Now, that vertical asymptote is the location that makes this inside piece of the logarithm equal to 0. So if I take x plus 2 and I set it equal to 0, then I solve for x. I end up getting x equals negative 2. This is the location of the asymptote. Once again, it is a vertical asymptote, and we can only reach it if we were able to get to positive or negative infinity, i.e. getting closer and closer and closer to the value of x equaling negative 2. So if you can want to think about it, you can say that my right end limit and left end limit, which aren't quite accurate now, are now the limit as x is approaching negative 2, and it's coming in from the right. Make sure you can see that graph coming in from the right. Zoom out just a little bit for you. And our curve does this. Now, this is a special curve. This curve is called increasing, and it's at a decreasing rate. And the decreasing rate is because it's approaching a flat horizontal. Now, keep in mind that it does increase infinitely, even though it gets flatter and flatter and flatter and flatter. So it does have that right end rule for the limit as x approaches positive infinity for this function f of x is positive infinity. Once again, it's still increasing at a decreasing rate. I'm going to write that down. Increasing at a decreasing rate. Now, we can see that we'll never reach that negative 2 for the value of x, and this is where our domain comes in. The domain is x is an element of the real number set such that x is greater than negative 2. Now, you'll notice this is not going to be or equal to, because we will not get there unless we could get to the imaginary value of what? Infinity, negative infinity. Now, we can put our brackets around it. That does make it a nice domain. So this is our domain. Now, we do know that there is a y some point on our axis when y equals 0. This is actually solving. So in order to solve, that's another skill, and we'll be taking a look at that shortly in a moment. Let's take a look at another example of a domain. Y equals 2 minus log base 2 of x. Now, sometimes it's easier to look at it in its HK form, or standard form, which shows us the vertical shift. We now know that we will be looking at our x-axis value, that x-intercept, being shifted up on our graph by 2. Well, we're still going to take a look at that inside piece right here and say that x has to be greater than 0. And lo and behold, that is our domain. So we now have a graph that has been shifted, but now be careful because this is going down. Okay, notice that this is that reflection through our y-axis. X-axis here. So let's just see our graph. Normally would be going like so, shifted up, but now because this is a minus, this is now going down. and looks like so. Notice the limit as x is approaching the zero value from the right for this function is going to be positive infinity. Once again, this is now a new type of curve. Notice that this is now decreasing at a decreasing rate. Decreasing at a decreasing rate. Make sure you can see me writing that. And once again, it does have some x-intercept, but once again, that is also the solving. So we're going to just put our domain. X is an element of the real number set such that x is going to be greater than 0. Alrighty. Now, in order for us to have a value that's less than a number, we're going to have a negative x. Let's take a look at a situation where we have a negative x. Let's take a look at y equals log base 10 of 3 minus x. Boom, 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 boom. Notice right here, we have a situation where when we take the inside part, our 3 minus x has to be greater than 0, which means instead of moving the 3, I'm moving the x. And now I can see that x is less than 3. Where are we putting our graph in? There's our axis. This time, we're approaching 3 from the left. So we have x equaling 3 here, and our limit is x is approaching 3 from the left for our function. It's now negative infinity. Notice we now have a left-end rule, and this is now the limit as x approaches negative infinity for the function, and it is positive infinity. This is a new curve. Notice this curve is now slanting downward. This is now decreasing at a decreasing rate, increasing rate. Make sure I get that right. Increasing rate. And that's because it's heading more perpendicular. Notice how the curve makes that end go more perpendicular, right up and down. Notice, compare it to this one. The decreasing rate's making it go flat. See how it's getting flatter? And an increasing rate, or increasing at the decreasing rate, is now going up, but going flatter. Going up, but going flatter. Going down, but getting flatter. Going down, but getting steeper. Well, that means that we could have increasing at an increasing rate happening on that other side. And let's take a look and see what that one would look like. This would be y equals, let's do negative natural log, and we'll do 2 minus x. And now I have a graph that has the domain. X is an element of the real number set. We take this 2 minus x, say it's greater than 0, 2x, such that x is going to be less than 2. There's my domain. We know it's on the opposite side because we have the minus x, and we have it flipped. So it's now going up. And notice this is now increasing, and we can see it's increasing at an increasing rate. And this is how we find domain. So let's just make sure we found each of our domains. We have the domain of our first function. We have the domain of our second. We can clearly see the domain of our fourth. And you'll notice I started but forgot to finish the domain of the third. Let's just finish it. The domain is x is an element of the real number set such that x is less than 3. Okay, let's take a look at a couple more now. This time, let's not draw the graphs. Let's just go directly to it, shall we? And they're going to start to get more difficult as we go. X plus 2 over x minus 1. We're now saying that this entire thing has to be greater than 0. Well, let's just see what's going to happen. If we have to have it greater than 0, we notice that we want to make sure that we don't use that x equaling 1. All right, notice that's going to give me a 0 in the denominator. As long as I don't use a 0 in the denominator, let's see what happens in the numerator. X plus 2 greater than 0, x being greater than negative 2. Well, wait a minute. If I put a negative, I'm going to get a negative down here. I will still end up getting a positive in the numerator. So that becomes a little bit of an issue. Notice that we have a situation where we can have a negative, double negative situation if we use these values, but we'll have a negative inside if we use values that are in between that will yield a specific negative result. So we're actively talking about something very, very different here. We can see that we have this restriction, but we want to make sure that this isn't going to be a negative number. So the question becomes, when will it? Now this requires me to look at what is referred to as a sign chart. I'm going to use my negative, my 1 here, and a negative 2 down here. Now the 1 is my asymptote, and I'm also going to put a perpendicular dashed line there. This is referred to as a sign chart. And it allows me to figure out products, x plus 2 and 1 over x minus 1. Now you'll notice if I use anything larger than a positive 1, I'm going to get a positive from this result, and I will get a positive from this factor. But if I plug in a value that's in between these two, now I get a negative result. It continues down here if I use a negative number less than negative 2. But then I look up here and I say, well, what's happening in between? I get a positive here, and I get a negative here. Once again, we know that from this part right there. Notice that the product is a positive result, and then a negative result, and then a positive result. So I now know that if I want to have a positive value here, I have to have a value that is greater than 1 and or values that are less than negative 2. And the real issue is having anything that is equal to negative 2 that will give me a 0 in the numerator, which I'm not allowed to have, or giving me a 0 in the denominator, which is absolutely forbidden, but where the result will be positive. So I now can state that my domain is x is an element of the real number set such that x has to be less than negative 2, or x is going to be greater than 1. And I'm going to put it in order as our number line, just so that it is more correct. Okay, let's take a look at another example. Let's now take a look at a situation where we have more than one logarithm. Because if I have more than one logarithm, I have to make sure that it's true for both. Now you'll notice that means that I have two statements in this one. My x minus 3 has to be greater than 0, and 2x plus 1 has to be greater than 0. And I have to make sure that both happen. Just like with the problem that we had with our sign chart, we're working with both, the result was a positive. Well, now I need to make sure that whatever value I plug into this, I get a positive value and non-zero. Greater than 0 at 3, 2x greater than 0 at -1, x greater than 0 at -1/2. We're now looking at a number line, and I can see that on this side, these work starting at 3, and these work here starting at -1/2. But we want where both happen. This is an intersection, where they overlap with each other. Okay, that's what gives me my domain. Let's take a look at another one. The natural log this time of 2x plus 5 minus the natural log of 2x minus 7. And I have a y. Once again, the inside piece, 2x plus 5, has to be greater than 0, and 2x minus 7 has to be greater than 0. So x has to be greater than -5/2 when I solve, and x has to be greater than +7/2. Looking at a number line, here is -2.5, here is +3.5, and we want to make sure that both are true. Notice that requires me to have the values that are greater than 3.5. So my domain is x is an element of the real number set such that x is greater than 3.5. And I'm just going to be consistent with my last answer and make sure that I set them up from left to right. Let's do one more. This time, let's go back to those fractions and see those more difficult ones. Let's take a look at y equals the natural log of 2x over x plus 2. Once again, we have to make sure that we do not have a 0. So x plus 2 cannot equal 0, and therefore x cannot equal -2. But we're also looking at the 2x being greater than 0, and therefore we have x being greater than 0. We're now going to try and figure it out by making our sign chart, putting on our -2 and our +0. Or it's really not positive, it's neutral. Neither positive nor negative. It is even though. Alrighty, we're going to put our factors. A 2, an x, and 1 over x plus 2. Now I know some people think that it's really silly for me to break the 2 from that x, but it is a factor, and we have to remember that. And occasionally, we need that negative when a negative happens. So I'm just going to put it up here just to make sure that I am being consistent. We can see positives, negatives, and positives. And when we put in positive values, we can see it's positive here, it's going to be positive here, but it'll be negative here. Now notice, in this situation, this is always negative, and therefore we can't use it. This area will be negative, and we can't use it. This area is always positive. Alrighty, so if we're looking for values that are greater than 0 and we can't use -2, then if we use all values greater than 0, -2 is already off limits. So that will be our domain. The domain is x is an element of the real number set such that x is going to be, let's make sure I do left to right again just to be consistent, 0 is less than x. This is how we find domain, and this is one of our primary skills that we have to be aware of and be able to do. I hope this has helped. Please remember to click like if you felt that this was useful. Thank you very much, Hornets, and please have a very good and safe weekend. Bye-bye now. Cheers.